All right, today we're going to look at the double angle identities. Our goal is to be able to derive and prove the double angle identities. We love that. And we're going to have a little go at applying the double identities and some problem solving questions. First off, we are going to show that sine 2 theta is equal to 1 minus 2 sine squared theta. I will do the proof for you here. We're going to start off with this diagram. Help me a little bit with the proof. So, I want to find out in order to do this proof, I'm going to do a geometrical style proof. So I'm going to look at this line here. This is the line BC. How long is the line BD? So BD, so I'm going to say from unit circle, how long is the line BD? BD equals sine theta. We can see in the diagram that the length of the length of BC is going to be twice that, isn't it? So we can say that BC is equal to 2 sine theta. So next up, I'm going to switch again and start again. I'm going to come from the cosine rule. So from the cosine rule, we can say that BC squared is equal to what from the cosine rule? Have a go at writing this down for yourself. So we should get 1 squared plus 1 squared minus 2 times 1 times 1 times the cosine of the angle. What's the angle going to be? No, 2 theta. Simplifying that, we get BC squared equals 2 minus 2 cosine 2 theta. All right, so let's insert equation 1. This is equation 1. This is equation 2. Insert equation 1 into equation 2. That's going to give us 2 sine theta squared equals 2 minus 2 cosine squared theta. If we expand the left-hand side, what will we get?
4 sine squared theta.
4 sine squared theta equals 2 minus 2 cosine 2 theta. How can I simplify that equation? Divide everything by 2, what will it give me?
2 sine squared theta is equal to 1 minus
2 sine squared theta is equal to 1 minus
cosine squared theta.
cosine
Squared theta.
2 theta, not squared. We will look at the equation that we're trying to prove. Just rejig this now to give cosine 2 theta is equal to 1 minus 2 sine squared theta. Quad erat demonstrandum.
What does this have to do with
That is the double angle identity for cosine. So we're going to use that double angle identity for cosine. We've been given it now. Cosine of 2 theta is 1 minus sine squared theta. And we're going to prove that it can be rewritten in this form. It can be rewritten in this form. Would you like to have a go at that for yourself? Have a go at that for yourself now. I'll give you 3 minutes. All right, so we're given this, we need to show that. So what we can do is we can start with the left-hand side, which is the cosine of 2 theta. We can replace the left-hand side using the right-hand side. This is, we can replace the left-hand side using, so the left-hand side of both equations is the same. I'm going to replace it using the angle identity given. So that means that has to be equal to this. So I'm using given. I'm using the given identity. So now I'm going to continue working on this side. I want it to have a cosine in it. I can see I need a cosine in it. So I need 1 minus 2 bracket. I can replace sine squared theta with what expression? I can replace it with 1 minus cos squared theta. Where has this come from? Yep. Ellis, what's the name? I'm using the Pythagorean identity.
So why is there a 3 equal sign?
I'll explain that at the end. So then I just need to expand the brackets. I'm going to get 1 minus 2 plus cosine squared theta. And I can rearrange this now into, 2 theta, 2 cos squared theta. I can rearrange it to 2 cos squared theta minus 1, which is the right-hand side of the equation through. Yeah, so Gustav asks, here I'm using the symbol for an identity. I should really be using it in the other one. Well, I messed up there on that one. Here on this one. So these are identities. What is an identity? An identity is true for all values of x. An equation is only true for certain values of x. So when we have an equation, we can solve it because there's only certain values of x for which it is true. An identity is true for all values of x. And that's what the 3 lines are.
It's written 1 minus 2 12 cos theta.
Plus 2. All right, next one. Given cos 2 theta, 1 minus sine squared theta, show that sine 2 theta equals 2 sine theta cos theta. I shall do this one. This is the double angle identity for sine. This is the double angle identity for sine. I shall start with this one. All right. So I'm going to start with the Pythagorean identity. So the Pythagorean identity. Pythagorean can be written as sine squared x plus cosine squared x equals 1. So if I let x equal 2 theta, that implies I can rewrite this as sine squared 2 theta plus cos squared 2 theta is also equal to 1. As long as the two x values are the same, it doesn't matter what they're true. It's an identity. It's true for any value, any angle. So the angle can be x, can be theta, can be 2 theta, can be 10 theta, can be root 5, 6, whatever, can be anything. As long as the two are the same. So cos 2 theta here, cos 2 theta is given there. So I'm going to insert the given identity, which is the double identity for cosine. Insert the double angle identity for cosine. If I insert it into here, I get sine squared 2 theta plus, and I put this in 1 minus 2 sine squared theta all squared minus 1. So I've taken the cos of 2 theta here, and replace it with that. Now I need to expand the bracket. Sine squared 2 theta. Alright, so if I expand the bracket, help me out with this one, what will I get? Let me take E set. 1
plus 4 sine squared
minus 4 sine squared theta plus 4 What is sine squared theta squared?
4 sine to the power of 4. Yeah.
Sine to the power of 4 theta.
Small squared.
What's the easy cancellation here?
Sine squared.
No, what's the easy cancellation?
4 by 4.
No, what's the... Start with the easy bit. Let's cancel those two. If I cancel those two, and then I'm going to rearrange it. Look at the equation I'm aiming for. Look at the equation I'm aiming for. On the left-hand side, the angle is 2 theta. On the right-hand side, the angle is theta. So here in this equation here, I'm going to move everything with 2 theta to the left and everything with theta to the right to start aiming for where I'm heading. I'm aiming for this. So that's going to give me sine squared 2 theta is equal to, and if I move this across, I'm going to get 4 sine squared theta plus minus 4 sine to the power of 4 theta. So everything with a theta I've got on one side, everything with a 2 theta is the angle I've got on the left, because that's how the identity I'm aiming at looks for. Now, let's factor. We factor the right-hand side. What can I factor out of this?
4 sine squared.
4 sine squared theta. 4 sine squared theta. What will be in the brackets?
1 minus sine squared theta.
1 minus sine squared theta. I can substitute using the Pythagorean identity. I can substitute on this here on the right hand side using the Pythagorean identity. What will it become? 4 sine squared theta. And then what can I replace? 1 minus sine squared theta.
Cosine squared theta.
Cosine squared theta.
So Tuesday's revision.
Stay focused on this lesson. Okay, so look at what I've got. Look at where I'm heading. What can I do to get there? If I square root both sides. Square root of this is going to be sine 2 theta. The square root of 4 is 2. Square root of sine squared is sine theta. Square root of cos squared is cos theta. Quad era demonstrandum.
That makes sense.
Nice, I'm glad. It would have blown your brain at the beginning of this year.
So why do we need like for example
Why do we need you? So what these help us with simplifying trigonometric equations, simplifying trigonometric expressions, solving equations, making further proofs. We use these for further proofs in calculus, understanding complex numbers. It's a base skill that we use, like quadratic equations and things. A base skill we use in a lot of further mathematics. It's also a good area for you guys. It's a good area at this point to expand your proofing skills. So this type of it's a good area to practice proofing skills.
So for example, on the major, we're gonna have to redo this.
Why are they removing
I don't agree with it.
then students will have to take 3 classes of 2 more. Yeah, they have to take 3
Pre-calculus should be a grade 11 course for people that I am free extended. All right, so let's have a look at this next one. All right, so let's have a look at this one. We'll do it together. We're given that sine theta equals 3 over 5, and we're asked to find sine 2 theta in the interval 0 to pi over 2. So, what's our first step going to be? No.
Pythagorean identity.
Oh,
You draw a triangle with the
Pythagorean.
Pythagorean identity. What will that do for us?
I have no idea.
So the Pythagorean identity is sine squared theta plus cos squared theta is equal to 1. Timon.
So it's gonna help us figure out cos squared theta by taking away sine squared theta.
So 3/5 squared is 9 over 25 plus cosine squared theta equals 25 over 25. 25 over 25 is fine. We want cosine squared theta.
Plus minus 4.
Couldn't we usually just prove that sine theta is equal to
Sine.
2 sine theta cos?
What would you do for cos theta?
What I
What would you do for cos theta? So the cosine of theta is equal to plus minus 4 over 5. As Mark said earlier, let's draw the unit circle, look at the problem, think about it a little bit. Our angle that we're after is in the first quadrant. What does that mean about the cosine value?
It's positive.
So we can say that theta is between 0 and 2 pi, which means that the cosine of theta is greater than 0. This implies cosine of theta is cosine of theta is equal to 4 over 5, which tells us that the sine of 2 theta equals 2 times 3 over 5 times 4 over 5. Which is 24 over 25.
Wait, sorry. I didn't get that word. What is
So this is in
how is
because it's 2
sine
theta, so you're multiplying it by 2.
Theta.
You're multiplying it by 2.
Good stuff.
It's sine 2
So I get that sine 2 theta is 2 times 3 over 5 is 3 over 5 is but I don't get what 4 over 5 is.
Or you understand the previous question of
Figure
this.
out the sine.
Yeah,
Yeah, I don't know where the equation is 2 sine 2 theta is equal to sine and triangle when you do Pythagorean like no, it's because look at the equation.
Oh, wait.
Sine
What if we
theta is equal to
Oh
2
yeah,
sine
sine
rho
2, we just
times
did it. We
cosine.
just did
No,
it.
I get
What
it.
is
No, sorry, we just did it. 2 sine 2, sine 2 theta is equal to 2 sine theta cosine.
We use the double angle identity sign.
So that's anyways, and then try to put 3, 4, and 5 on sides, right?
All right, are we ready?
Doesn't happen.
Yes. Are we ready? Let me just make sure I'm still recording. Yes, I am. Myrna, are we ready? Have a go at this question for yourself. You get 5 minutes. You get 5 minutes for this question. Can we have quiet? Right, let me get through this question. So show that cosine 2x equals sine x can be written in this form. All right, so I'm going to replace the cosine double angle here with the double angle identity. So starting off at A, I've got cosine of 2x equals sine x. Let's insert the double angle. So you have 3 forms of the double angle identity for cosine. You've seen 2 so far. You've seen it on the test.
Is the double angle identity listed in the formula?
Yes. But when we want to use it here, look at what we're aiming for. We're aiming for something just in sine. So there's one of them that's just sine. So we'll use the 1 minus 2 sine squared theta. Because now our equation is just in sine. And then it doesn't take much just to sort of move these things across, and we can rewrite this as 2 sine squared x plus sine x minus 1 equals 0. That's A. Hence, solve this. So what that basically means is saying, hey, we've already shown you that this equation can be rewritten as this equation. So use it. So we're asked to solve that equation. So that tells us that 2 sine x squared plus sine x minus 1 also equals 0. Factor it. How should we factor this? We can factor it directly just by looking at it if you want. Otherwise, the easier routine is to let t equal sine x. So that gives us 2t squared plus t minus 1 equals 0. To factor this, we've got 2 times minus 1. So 2 times minus 1 is minus 2. And we need a 2 minus 1 equals 1. So doing this, we can see that we can split this into 2t squared plus 2t minus t minus 1 equals 0. And then factor out the 2t. We get t plus 1. factor out the -1, and we get t plus 1.
Wait, so the first one was so easy.
And then we get 2t minus 1, t plus 1 equals 0. So sine 2 sine x minus 1 is equal to sine x plus 1.
So do you have fun doing this?
Yes?
I know you enjoy like giving us cake with this. Sir, I don't understand when you're right, it's hitting quadratic.
I'm just doing a variable substitution so it appears more like a quadratic.
Exactly. Okay, no, I know right now.
It just looks easier. With the A block, I show a lot more steps. So with the C block, we just go from this straight to that and we'll go.
Because they're smarter than us, apparently.
They're just judging.
Apparently.
You know he probably says that to like the people.
All right. Are we okay with the factorization?
Sir, it's just t is equal to 1 and
Plus is over.
I mean negative.
Are we okay with factorization?
Yeah.
All right. So that gives us sine x is equal to a half. Sine x is equal to -1. So then we need to solve the two equations. Solving this equation, what is the primary angle for where the sine is equal to a half?
30 degrees.
Are we in radians? Yeah. So x is equal to pi over 6 plus n to pi. What is the pi minus pi over 6?
Pi minus pi was
5.
It's minus 5
5 pi over 6 plus n to pi. And this is the solution set for that equation. The second equation, we might do a solution just using the unit circle. -1 is here. So the y value being -1 would hit us here. So what angle is this one?
270.
X is equal to 3 pi over 2 plus n to pi. So this is the solutions. Now, the question says where the variable x is in the interval minus pi to pi. So that means, yeah, but it's not the whole thing. It's from here around to here, this particular way, starting at minus pi and going around to pi. So the solutions from this one here, would be here at pi over 6 and here at 5 pi over 6. And they're in that interval. We don't need the n2 pi's. But 3 pi over 2 is down here. We need to rotate it back by, let n equal -1, rotate it back by 2 pi, and that will give us another solution at minus pi over 2. So x is equal to minus pi over 2, pi over 6, 5 pi over 6.
Sir, you went from quadratics to radians.
Isa.
So where did you get that 5 pi over 6?
So when it comes to solving, one of the things you really have to make sure you're memorizing is your solution of trigonometric equations. I think I put it in this one. Just see.
Sir, 100% sure this
Over
is
6
like
is
an
30
essay.
degrees.
180 minus 30 is not 5 pi over 6.
It's literally 5 minus 5 over 6.
That's crazy.
Minus what?
5 over 6.
Maybe I put it in lesson 2.
Yes. What's 180 minus 30 degrees?
Okay, lesson 2.
That does make sense.
Lesson 2 from this unit, I presented how to solve trigonometric equations again. And there's one of the lessons at the end of Unit 1 where we first introduced it. When we introduced it in Unit 1, I did quite a few examples and we went through it for degrees. And then for this unit, I added and showed you how it is for radians. So when you're solving sine x equal to a, you find your theta by finding the arcsine of a. This will give you your theta. So x is equal to theta plus n2 pi, that's your first set of solutions. For the sine function, you have a second set of solutions, which shouldn't say pi degrees, it's a mistake. I've not deleted the thing when I copied and pasted. So the second solution is at pi minus theta, or 180 minus theta. So your second set of solutions comes at 180 minus theta or pi minus theta.
So in the exam, do we have to give our answer in
Can I-
radians?
Focus on this bit. For that question, depend typically in radians, unless the question specifies degrees. Cosine is the easiest one. We can have two angles at plus and minus theta. Tangent is also easy because the period changes to pi instead of 2 pi. So it's just theta plus pi. The reason comes from the unit circle. When we're solving a sine function, it looks like this. This is the line y equals sine theta. And it has two solutions. One here at theta, and another one here at pi minus theta. But this is minus theta, and pi sits here. So with sine, you get two solutions like this. With cosine, you get an angle like this one at theta, and you get an angle like this at minus theta. So you get two sets of solutions for cosine, because this is the line x equals the cosine of theta. Tangent comes because it's sine over cosine, sine theta over cosine theta. And that means that when they're both positive, tangent will be positive. When they're both negative, tangent will be both negative. So the tangent ones, when you have your theta, your second set of solutions is over there, like this, where this angle here is theta, which is why you have pi plus theta to give you your second set. And then we have pi and come around again one more time. I highly recommend, there's two things you need to memorize for the test on trigonometry. You need to be able to generate your exact value table. You need to be able to generate your exact value table, and you need to know these formulas. These are not given on formula sheet. The double angle identity, the cosine angle identity, these are all on formulas.
So is this slide on the card?
This slide is on lesson 2.
That's a 2 of this unit.
Let me close the lesson off. This question is a homework question. We will do it at the start of next class. It must be finished before the start of next class. It's an exam question. This question comes from an AASL exam paper. Have a look at this one. Homework is to do the double angle identity practice. There's an additional paper if you wish to do it. You must also complete this before the start of next class.